In today's lesson, we were analyzing the effects of additive inverse and multiplicative inverses. In the first examples, we had to write the sum and then find the equivalent expression by combining like terms. So if I do 2x plus negative 2x plus 3, the 2x and the negative 2x becomes 0 because they are additive inverses. 2 and negative 2 add to 0, so the answer for this would be 3. If I'm doing 2x plus negative 7, plus the opposite of 2x, which is negative 2x. You'll notice when I write a subtraction, I will automatically change it to adding the opposite because I know eventually I'm going to be needing to use the commutative properties and the associative properties, so having it change to addition allows me to use all the properties once I start to simplify. The 2x and the negative 2x again will cancel to 0, and this answer is negative 7. For the final example, it's the opposite of the expression 5x minus 1. So I'm going to write that as the opposite of 5x plus negative 1 plus 5x. The opposite from the first expression doesn't affect the 5x because it's after the and. We were talking about the other day about treating the negative as distributing a negative 1 because it does the same effect as finding the opposite. Multiplying by negative 1 will find an opposite of a value. If I do the negative 1 times 5, it's negative 5x. Negative 1 times negative 1 is a positive 1. And then I bring my 5x over. Again, the additive inverse is negative 5 and 5 cancel, so I have no x term, and the answer would just be 1. For multiplicative inverse is the idea of finding a reciprocal, a number that you would multiply by the fraction to get 1. So if I have 1/5, its reciprocal is 5. Then I bring my other expression over, 2x minus 1/5. Use the distributive property to remove the parentheses. So 5 times 2x is 10x. 5 times 1/5, I have the minus sign. 5 times 1/5, they are reciprocal, so we'll multiply to be 1. Multiplicative inverse of 2 is 1/2. I distribute the 1/2 to the 2. They are inverses, so it would just be 1x. And the 1/2 times 4 is 2. For the final example, I need the multiplicative inverse of that expression. It will work the same way as it would if it was a single value. I will change the position of the numerator and denominator. So it would be 3x plus 5 with a denominator of 1. Since the denominator is just 1, divided by 1 doesn't change the value. I can just write it as 3x plus 5. I'm multiplying that by a third, so I'll just use the distributive property. 1/3 of 3 is just 1x. They're multiplicative inverses. And then if I multiply 5 times 1/3, set it up on the side here, you can see 5 times 1 is 5, 1 times 3 is 3, and it can be left as the improper fraction 5/3. So x plus 5/3.